Hi everyone. In this video we're going to go over a few physics regents problems that relate to waves, and we're going to practice calculating frequency and wavelength. So the first question says, a tuning fork is used to produce a sound wave having a frequency of 512 Hz. What is the wavelength of the sound wave in air at STP? The first thing I did was I annotated this question using cubes, meaning that I circled the numbers and units. In this case there was just one number given. I boxed the keywords and I chose sound and STP, and then I underlined the unknown, which was wavelength. So based on that information, I know that wavelength is my unknown. That's what I'm looking for. The variable for wavelength is this Greek letter lambda. It looks like this. And then I also know f is equal to 512 Hz. That's all the information that is kind of given to me outright, although the keywords help me find one more piece of information that I need to know. So sound and STP are two words that I picked out because that's going to lead me right here to the front page of my reference table. Speed of sound in air at STP is equal to 3.31 times 10 to the 2 meters per second. So STP stands for standard temperature and pressure, which isn't as important. I just think of it as kind of a keyword that helps me remember I need to look something up on the reference table. So once I have that, I have everything that I need for this problem. I'm picking a formula that involves all three of these variables. So V equals F times lambda, or velocity equals frequency times wavelength. I'm plugging in my numbers, and then the last step that I'm going to take is to divide both sides by 512 so that I can get lambda by itself. When I do that, I see that the wavelength is equal to 0.646 meters. Question 2 is similar, but one big difference is that we are looking at a light wave this time. So as we go through this problem, we'll see how that is similar and different to solving a problem related to a sound wave. The first thing I started with was annotating. A beam of light has a wavelength of 4.5 times 10 to the negative 7 meters in a vacuum. The frequency of this light is, and we have to figure out what that is. Light is important and vacuum is important, and those are, again, things that we're going to look up on the reference table. I know that I'm looking for frequency, so F is my question mark. They gave me the wavelength, so I wrote lambda equals 4.5 times 10 to the negative 7 meters. And those keywords, light and vacuum, show me that I need to look something up on the front page again. And right above where it says speed of sound in air at STP, I see speed of light in a vacuum. A vacuum just means empty space. So most of the time in these problems, you're going to be using this speed of light. If they ever say speed of light in air, you're going to assume it's the same as in a vacuum. So that's the number that I'm going to take for my speed. So V is equal to 3.0 times 10 to the 8 meters per second. I am going to use the same formula. This time I am solving for frequency. And at this point, once I have my numbers plugged in, I know that I need to divide both sides by 4.5 times 10 to the negative 7 in order to get F by itself. When you're dividing with scientific notation, it is very important how you plug it into your calculator. So both of these ways would work. The top one is my preferred method. I use this E button. 3E8 divided by 4.5 E negative 7 is just faster to type into the calculator, and there's less room for mistakes. That gives me 6.6 repeating, E14. The E14 means times 10 to the power of 14. So this E button helps me, it saves a little bit of time when I'm typing it into my calculator. I get that by pressing second and then the double E button right here. Two capital E's right next to each other. So that's where I find that button. If you don't use that button, that's fine. You can type it out, 3.0 times 10 to the 8 divided by 4.5 times 10 to the negative 7. However, you must use parentheses. If you don't use parentheses, you're going to get a different exponent, which may not seem like a big deal, but it will be the complete wrong answer. Once I get that plugged into my calculator, I get 6.67 times 10 to the 14 Hertz, and that's going to be answer choice 4. I round that to 6.7.